Good afternoon, everyone, and thank you for joining us at this very interesting session with our GeoAtlantic project. The session's name is Innovating Geothermal Heat Pumps, Status Quo, and Outlook for the Next Decade. My name is Dan Stefanica. I am the head of projects here at EHPA. Most of you hopefully know me. If not, give me a call. We have some interesting project calls coming up in the Green Deal. We were just talking about that with the rest of the speakers. So thank you again for joining. And of course, I hope you can hear me and I hope you can see me, as is the way we're conducting things nowadays, right? Just a brief overview of today's agenda. So I'll just do a quick introduction into the GeoAtlantic project. Then we have 5 very interesting presentations of about 10 minutes. Please don't judge anyone if they go to 10 minutes and 30 seconds. We are all very understanding here. Of cutting edge technology of geothermal energy, of heat pumps and their uses from 5 very interesting speakers that I will introduce you one by one when the time of their presentation will start. Then we'll have some time for questions and answers. Again, feel free to put your questions at any time in the chat box, and I will show you later on how to do that. And then at around 3:30 Central European time, we will end this particular session and encourage you, because you're already here, probably you know how to use B2Match to, well, set matchmaking meetings with other participants, as well as participate in the other sessions that we have. So what is this GeoAtlantic project that we're talking about? I mean, we have a lot of partners. Maybe some of you have already heard about it. Basically, when we applied for it and it was accepted, it was because we realized that we are in the midst of a transition, one that is focused on renewable heating and cooling, energy security, and the use of local resources. Now, many of the changes that this transition involves will be noticed in both megacities, the megacities of tomorrow, as well as small town and small communities. So this project serves both ecosystems as a way to change the mindset of users, the policy, and the technological deployment for the future. With geothermal resources, heat pumps, and the involvement of local communities, offering a glimpse of the future. No more so than in the work that we're actually doing in this project. By, as you can see on the screen, encouraging all sectors to transition to a low carbon economy, promoting the generation and distribution of renewable energy, promoting the economic, social, and environmental contribution of renewable energy, and the gains that we get from its enhanced efficiency. Now, as you can see on the screen, the partners are quite diverse. It's from Spain. We have partners from Portugal, the United Kingdom, France, Ireland, and well, EHPA is from the EU. So Belgium as well. Let's call it like that. Again, just a little bit of housekeeping rules before we start. You can use the questions and answers box, and at any time a question pops into your mind, we will go through them at the end of the presentations, and we will try to go through all of your questions. If some of them are not answered, we will do our best to answer them as a follow-up. This presentation is recorded, so you will receive a recording of the presentation as a follow-up. And all of the presentations you will receive as well as a follow-up. So you'll have all the contact information as well as the recording, so you can get in touch with the speakers and everything, as well as me, right? So with that being said, and without any further ado, it is my pleasure to introduce the first speaker of today's session. His name is Adrian Perez, and he is a sales engineer at Ecoforest. He is a mining engineer specializing in energy. focused specifically on renewables and especially on geothermal energy and projects on ground source heat pump installations. After university, he started working at Ecoforest and has been working in the technical sales department of Ecoforest, doing the double roles of sales and technical for more than 3 years. So, welcome, Adrian. The floor is yours. Hopefully you can control the mouse and keyboard, and please go right ahead with your presentation.
Thanks for the introduction. First of all, I would like to say thanks to the European Heat Pump Association for letting me act as a speaker today. I'm glad to be here, especially talking about this topic, innovation in ground source heat pump, because it's something that at Ecoforest we are very proud of, and it's one of our main line of business, innovation. So today I would like to do an introduction about our solutions for ground source heat pumps. Okay, here it is, our laboratory. I started the presentation with the laboratory because it's something that we are doing a lot, R&D. So if you have in our YouTube channel, you have a record of all of our headquarters, and you can see how amazing is our laboratory, where we develop all our products and we bring to the market every year new products. For the ones that they don't already know Ecoforest, I would like to do a brief introduction about us. Ecoforest is a Spanish manufacturer. We started in 1959 in the renewables energy, in the biomass field, through pellet stoves and boilers. In 2010, we started with heat pumps, and during these 10 years, we have grown immensely. Thanks for two bets. We are betting for the innovation and for the international expansion. In our team, there are a lot of people, technical people in all the sectors, in all the areas, in the R&D laboratory, in the production lines, and also in the offices like me. Thanks to this bet for the innovation, nowadays we are present in more than 14 countries. We always say that we are not selling heat pumps, we are selling solutions for each case. So for that reason, we have plenty of reference installations all over the world and in different type of buildings, hotels, national buildings, museums, pools. I think that ground source heat pumps now are suitable for each type of product, and it's something that we need to promote also. Today we are going here to talk about the innovations that we are doing, but I would like to start with what we did in the past, 10 years ago when we started in this business. When we started 10 years ago, we tried to bring to the market one product technologically different to the rest. And our bet was to make our installations compact and simple. For that reason, we bet for the inverter technology in ground source heat pump, that it was a technology very used in exhaust heat pump at this moment, but not in ground source. We also include the possibility to do cycle inversion in the unit. We introduce units up to 22 kilowatt in single phase. We have one model called EcoGeo 522 that is one compressor that it modulates from 5 kilowatts up to 22 in single phase. In fact, there is the option to make a cascade up to 66 kilowatt with this unit. We have also the possibility to combine another collection systems, not just ground source. We can combine ground source with water, with air source, thanks to our air units. And these air units could be the only collection system, replacing at all boreholes sometimes when there is not technical possible to do boreholes collection. We also have the HDR technology. This is a heat recovery technology that allows to produce domestic hot water and heating or cooling at the same time, almost for free, the domestic hot water during the summer months. So this is the past, and what's next? Next, for us, there are 3 points that we need to speak about, and one is cooling production that I already mentioned, the combination with other renewable energies, especially with PV, and due to the F-gas regulations, now one of our main topics in our industry is the new refrigerants. I will go through these 3 topics. I will tell you why we need to speak about this and what are the solutions that we are bringing to the market. So, with cooling production, nowadays there are two main reasons to focus about that. One is the global warming that is affecting all Europe, especially in countries that there weren't heating demand. It was only heating demands. Now they need also cooling, and also the new architectural conditions that they are using more glass. They are using a lot of isolation. So sometimes cooling is also needed. For cooling possibilities, we have nowadays two options, that is passive cooling and active cooling. We inbuilt both options inside of the heat pumps. So we have models with passive cooling included as a default in the units. And also we have active cooling production through four-way valves like an air source heat pump in ground source. This is something that we are very proud of, and it's something that is getting, thanks to this, we are getting a lot of projects, because finally the result of the installation is very compact and very simple with a ground source heat pump. Another point, the second point that I would like to talk about is the combination with PV. Finally, there are two solutions nowadays in the market. The direct supply and the batteries. The direct supply is almost impossible with photovoltaic due to the fluctuations in the PV production. So we usually use these batteries for the electrical storage of the energy produced in our PV installation. Batteries are expensive and the long life of the batteries are short. For that reason, we are betting for another solution that is the thermal storage. We have developed a controller called EcoSmart eManager that combines the heat pump with other renewable energy sources. The eManager is connected to the heat pump and to the counter of the installation through a communication bus cable. What the eManager does is, when there is a surplus of energy in the PV installation, he told to the heat pump, okay, we have this amount of energy, you can use it. So instead of using 1 kilowatt per 1 kilowatt, we are multiplying this kilowatt that we are producing for 3, 4, 5, depending on the COP of the heat pump at this moment. So we increase the surplus temperature of each of the services. So we can do thermal storage in the domestic hot water, in the heating, in the cooling, or even in the pool. This product has another characteristics like the power limitation or the non-critical loss management, but what we have patented is this curve. If you look at the graph, in blue is what we are generating in the PV, and in orange it's what the heat pump is consuming. When the PV is enough for our heat pump, the heat pump totally adapts to this production, and this is thanks to the combination of our heat pumps with our software to the inverter technology. This is something patented by Ecoforest. This solution is very suitable for single houses. We offer a complementary product including inversor and batteries, but also for industry with amazing savings in industry especially. Just to finish with my presentation, I would like to introduce our last range of products, the Pro range. The EcoGeo Pro includes as propane, R219 as a natural refrigerant. We are betting for propane as a refrigerant because several reasons. One of them is the global warming potential. If you look at the graph, you can check the difference between the traditional refrigerants that we are currently using most of the manufacturers, R410A or R407C. The other manufacturers that in air source, especially, they are betting for R32. But if we compare with the propane, propane is a natural refrigerant, is more economical, it has several advantages for the atmosphere, and the production temperatures are higher. So it's especially important for retrofits. Here are the main characteristics of the EcoGeo Pro. You can check below the most important data of this unit, COP, sound level. But if you need the complete data sheet, I can share with you at the end of this webinar with all the information and all the technical curves. This EcoGeo Pro, it modulates from 0.5 up to 6. It includes the possibility of cooling. It includes the possibility of our compact units with a domestic hot water tank. As a default, there is included the circulation pumps from brine and production. and also the expansion vessels, we can combine with our air units, with the EcoSmart Team Manager, and also with Modbus, KineX, or BACnet. So this is this unit only includes 150 grams of refrigerant inside of the unit. So is the only product like this nowadays in the market. As I told you, if you need some further information about it, I can share with you. So our idea is with this project, fighting more and more in social housing projects and to use ground source in this type of projects instead of gas boilers. Nowadays, we are doing with our 19 kilowatt in these samples, for example, 312 units in Cortijo Norte, 69 in Idomos, or even in Netherlands, 89 single houses, ground source heat pumps installed indoor in each flat. But in this case, the collection is this air source collection with 2 big dry coolers on the roof. So thanks to all of you for your attention. Thanks again to the European Heat Pumps Association for organizing this event. If you need further information, you have my company details in this slide, and you can get in contact with me also through LinkedIn. So today we have a very good speakers. Now is their time.
Thank you very much, Adrian. That was very, very interesting, actually. And you touched upon many other things like architectural conditions, like the inverter batteries versus electrical batteries with the refrigerants, and why did you choose that particular refrigerant? And I would encourage Adrian to send me the data sheet after this session, so we can maybe put it as part of the follow-up package. So then everybody that is attending can take a look at it. Thank you so much, Adrian.
Thank you, Dan.
Now to move forward to our second presentation. The second presentation is from Javier. Javier is a full professor of applied physics at Universidad Politécnica de Valencia, so the Polytechnical University of Valencia. His research has been dealing with combustion engines, heat pumps, including air and geothermal heat pumps, and more recently, many forms of renewable energy. His research team, ICT Against Climate Change, is particularly focused in the use of information and communication processes in climate change mitigation, where renewable heating and cooling technologies are especially relevant. Currently, Javier chairs the Renewable Heating and Cooling Platform, where heat pumps have a special focus of interest due to their many applications and huge potential. So, Javier, the floor and microphone is yours. Please.
Thank you. Thank you very much, Dan, for your very kind presentation. I'm really happy to have heard the previous presentation from Adrian, because here in Valencia, we made research about geothermal ground source heat pumps back in the 2000, and it was also with propane, in which we saw a very interesting refrigerant with high potential for let's say, having less emissions in all senses. So I'm happy really to see that these technologies have been, let's say, they got more popular, and they have a chance in the market. So, but anyway, I don't want to speak so much about geothermal, and I would like to open the scope a little bit in this meeting and talk a little bit more in general about the challenges in the renewable heating and cooling sector, and what are the big and huge opportunities for the heat pump market in this let's say, in this context of the decarbonization of the heating and cooling sectors in Europe. So I will just represent our platform, the Renewable Heating and Cooling ETIP, European Technology and Innovation Platform, and just to mention that, well, in this platform we have really representatives of the basic of the most let's say, important technologies of renewable generation of heat and cool: solar, biomass, obviously geothermal sector, but also the heat pumps and the district heating and cooling thermal networks and thermal storage technologies. So these are, let's say, the basic sources, as we know here. And this is also here, you can see in the slide, the structure of the platform, composed of what we call panels. These are pools of experts, of people that voluntarily are contributing to, let's say, share their knowledge, share their expertise on these areas of let's say, expert of knowledge in the different sources of renewable heating and cooling. But we also have these horizontal working groups, which was quite a new development in the last years of the platform, where the basic ideas were to connect these technologies, these sources with the demand, with the people, the structures, the stakeholders in the society which really need heating and cooling, and give answers to the cities, to the districts, buildings, and also to the industry, which have very different, let's say, profiles of heating and cooling demand. So they need from these sources, from these experts, different answers and different approaches. So this, I think, was a big, let's say, innovation in the platform, and really an enrichment in our activities. And this, let's say, I think gives also quite a lot of chances to the different technologies, including the heat pumps, obviously, to give, let's say, the answers that these stakeholders are looking for. So what is the platform good for? We basically are producing documents, we are producing paper, but these are much more than paper. These are visions, these are strategies, these are shared experiences in which we are analyzing the different opportunities, the different challenges, and also trying to, let's say, guideline a little bit what could be the, let's say, the priorities for research, for innovation, for the European Commission. In this sense, we are very in touch, let's say, with these stakeholders at the official level in the EU, because they seek from us this advice on what could be, let's say, the best bets for these technology developments. Mainly, we can see here in the left side that we have more integrated documents, like very recently the Strategic Research and Innovation Agenda for Climate Neutral Heating and Cooling in Europe. This is a very ambitious document in which we give for the first time let's say, overarching answer from all these sectors of the demand and also of the sources on what could be, let's say, how the sector of heating and cooling could look like in the next 10, 20, 30 years, which is nowadays very important. We have to remind that our sector is representing the majority of the demand, let's say 48 to 50%, depending on the country. And this is a lot. And I think many eyes are looking at us, looking for answers, looking for what could be the approach to decarbonize the heating and cooling sector. In the right part, you can see that we also do, obviously, our, let's say, more, let's say, thematic, more technology-driven document strategies, including heat pumps, including biomass, including solar. These are, let's say, the view of the experts of these sources, how they connect to the heating and cooling demands of society. So I think these are the two parts of our, let's say, in the left you could see more this horizontal structure, and in the right part you could see more this vertical, let's say, source focused structure of our, let's say, documents. What have we found out in let's say, in this strategic research innovation agenda, in which I would like to focus in the next minutes of my presentation? So I think this is our new document, our new, let's say, approach here. And one, I think, very important part here is that we tried to really dimension what is the importance of the heating and cooling sector in the context, in the broader context of the European energy transition. I think this is very important. We lack of this type of picture, like other sectors have, like electricity, transport. They have this, let's say, very, let's say, I would like to say, very compact vision, because they are a few number of stakeholders there. Their technologies are quite, let's say, homogeneous, I would say. Whereas in our sector, it's much more complex. We have a huge variety of technologies. We have a huge variety of stakeholders, of producers, industry, etc. That, let's say, it's difficult to put on a let's say, on a label. But if we make this effort of putting together the numbers, putting together the statistics, what we see is that what we have seen is a continuous effort, a continuous growth in the share of our heating and cooling, renewable heating and cooling technologies in the last 11, 12 years. And not only that, in the, let's say, clean energy policy forecast of the European Commission called EUGO 3232.5, we see also that there's an increasing interest in the Commission to decarbonize the heating and cooling sector with the so-called renewable heating and cooling technologies, which are obviously our technologies. So it's not only that the trend is to an increased share of renewable heating and cooling, but also there's an increased reliance on this type of technologies in decarbonization. What you can see here in this graph in the orange part is that we are supposed to increase from 98.7 megatons equivalent oil in 2018, which is the last numbers we had, to 124.4 in 2030. So this is quite substantial growth. And how are we going to do this? So here we can see more or less the trend. So we see an increase in renewable heating and cooling. The question here is that there is more electricity, as it's commonly said, but let's say more green electricity, but not more electricity overall. So we need other sources besides of electricity to really, let's say, increase this potential of decarbonization, and particularly in the heating and cooling sector. So it's important to say here that in this, there are, let's say, one scenario in which we could say, okay, for 2040, we could go easily from this perspective to a 50%, let's say, of the share of renewable heating and cooling heat in this heating and cooling sector. Okay, this is more or less, let's say, a business as usual line of thought in which we could see the, let's say, the growth which is foreseen in the last 10 years projected in the future to 2040. In our sector, we have a different vision. We would like to say that why not? Why is it is not possible? What should it be to go to 100% decarbonization in the heating and cooling sector? Indeed, in our vision of 2013, which was the first document, we foresaw that the potential of the heating and cooling sector, the renewable heating and cooling sector, it would be possible to fully decarbonize the heating and cooling sector by 2040 if we really, let's say, work on the different sources, if we really deploy and work together with the stakeholders, with the cities, in a planned and ambitious program for renewable heating and cooling. So this could be, let's say, the main message in our strategic research innovation agenda, but not only that it is possible, but how it is possible. What really are the technologies that are the largest potential to really cover this gap from now to 2040 to go or to achieve this 100% renewable heating and cooling. Here we also have done this effort of statistically putting together the sources. If we look at 2040, what is the business as usual vision? We should really deploy and work in heat pumps. And there is a lot of reliance on heat pumps in this future, in this energy future in Europe. We of course have to work on what's so-called the derived heat, what this means cogeneration by renewable sources, and obviously in the solar heat, geothermal area biomass, and in this orange part you can see that what is the rest of the non-renewable sources of heat, gases, oil, and so on. In our 100% scenario, what we are, let's say, projecting, it would be possible really to grow much more. Biomass is really a source that is quite limited according to this, let's say, the natural limitations of the biomass as a heat source, but we have the heat pumps which have a much more potential for growth in this area, as well as solar, geothermal, and the other renewable heating and cooling sources, provided that we can have really integrated planning and the right market conditions to make these sources really competitive against what is nowadays a very cheap gas source, which is really a barrier, a huge barrier in the market to introduce these technologies. So here we're not seeing so much the technological barriers which are there and which really require a lot of innovation to make these sources cheaper, more available, with better planning in the cities and etc. But also to have a, let's say, even play field in the market against this cheap gas, which is not anyway going to be, let's say, penalized by the emissions, the greenhouse gas emissions, which are, let's say, as inherent of these fossil-based sources. So there will be a market, there will be a more even playing field, and we need our technologies, and particularly also a heat pump, in which you can see a big confidence, a big hope that heat pumps can cover substantial part of this future heat and cooling demand for the different stakeholders. So our SRIA is really proposing to unlock this potential from the different perspective, not only the technological, but also from creating these market conditions that may enable to unlock all these hopes and all this ambition for 2040, not for 2050, but for 2040, in which we really think it is possible to go much farther. So just to finish with 4 or 5 ideas on how this SRIA looks like, and I think I would really like to encourage you to look at it, because we have really worked together with cities, with industry and so on, to see what are the priorities, what could be really the main focuses for research in the next 10 years. And here we have identified some of the topics that could really help cities, for instance, or the other stakeholders, buildings, to go much farther in this decarbonization aim. So in buildings, we can talk about cost-effective retrofitting of old buildings, which is obviously the main goal, because most of buildings will be there, which are nowadays here, will be there in 2050. So we have to look how to effectively decarbonize all these building stocks. Also for historical buildings, how to integrate the different sources of energy in these building stocks, in the new buildings, also at micro CHP, let's say technologies that may not only enable buildings to, let's say, to use energy more efficiently, but also to produce their own energy. So I think this is all possible in this, and there heat pumps have a central role, obviously, as a electric thermal vector, which is very efficiently can convert from electricity to heat in this area. Obviously, energy systems integration, we have to look at, let's say, increasingly at certification schemes, at how to make architects, the building stakeholders, more, let's say, more effective at introducing from the first stages of design of the buildings these technologies in their, let's say, portfolio. If we talk about districts, we can see here also these topics which are very important, like the increasing efficiency and temperature reduction. We are talking about 5th generation district heating network with lower temperatures, in which also heat pumps can have a central role to really, let's say, connect the different energy vectors like electricity and heat and cool. We have to look at these decarbonization scenarios, evaluation for the strategies, and system integration. In, let's say, in the realm of cities, we can talk about technologies for integrated system solution. Here we have to look really at the system level, at a high and abstract system level, in which we have many different sources, vectors, and we have to, let's say, effectively plan and help the city planner really to integrate all these into their perspectives, to have tools and guidelines for the development and transformation strategies that could be even standardized in the future of the cities. Finally, if we look at industries, there's a completely different area in which is a completely different temperature levels, for instance, from very high temperatures in the order of thousands of and degrees in certain industries to temperature levels which are close to what industrial heat pumps could provide in the future. For instance, in the area of 200 to 250 degrees, there is a lot of industry which could really benefit from the new developments in the heat pump sector, which could really provide this type of temperatures. And just to finish with some messages here, that we really, if we work together, all stakeholders, we could achieve this decarbonized future let's say, sooner than we might think of. That we can really, through the work together in our platforms and with the stakeholders, let's say, work together, that together we are stronger, and that we have to really make use of, take chance of this integrated vision of the renewable heating and cooling sector as a, let's say, it's an important and let's say more and more coherent approach to the decarbonization of the energy future in Europe and to the energy transition. So thank you very much for your attention. I hope my presentation was clear, and I'm open for your questions now or perhaps a little bit later.
Thank you so much, Javier. So especially the last slide, it's always inspirational. And I strongly encourage you, as Javier said, to take a look at the RHC Platform website, where all these documents are uploaded. as well as take a look at all the other opportunities that the RHC has. For example, on the website, there's a database of renewable heating and cooling projects that you can easily sort through. There are many events coming up. Just off the top of my head, there's the Irish National Table. So there are many events focused on a particular country and what are the innovations relating to renewable heating and cooling in that particular country. And there's also, well, such a good community of experts and people that collaborate into making these documents that actually inform the policymakers and show them from vision to research to deployment. So strongly encouraged to take a look at that.
Thank you. I would like to add here, I would like just to add one sentence here.
Yeah.
It is all more and more important for the let's say the calls and the projects that are aimed at that to look at more integrated projects, even with different technologies. Okay, so I think this the RHC also offers an opportunity to come in contact with, let's say, with areas of RHC that are not, let's say, your area. Let's say. To come together with other experts and share some common, let's say, goals and P2B and projects. I think this is an increased opportunity and it's increasingly important now.
Exactly. So quite a different project, let's say, from the others. You would there are a lot of associations like EHPA participating. There's a lot of experts with expertise in different fields, and we try to put them together to see to look at the bigger picture, let's say.
Exactly.
So, thank you so much, Javier. If you have questions for Javier, just remember, put them in the chat or questions and answers, and we will discuss them towards the end of the session. To move forward to our third presentation, our third presenter is Carlos Oliveira. He is the CEO of HEN, Servicios Energéticos LDA. He has a postgraduate degree in public administration management and is a mechanical technical engineer, as well as an indoor air quality expert, IAQ. Thank you so much, Carlos. I hope you can change the slides and I hope everything will work well. The floor is yours.
Thank you, Dan. Good afternoon, everyone. First of all, I would like to thank the organization for this nice invitation and the opportunity to present my project that I have done personally here internally in the company. The company that I am the CEO, what we do here in Portugal, we supply technical solutions. We are an ESCO company. We invest in boilers, in wood boilers. We have in this moment 11 contracts in performance. But our major investments are in street lighting. We have several municipalities that our public lighting is ours. We have the technology. It's our technology, the communication. We have developed a system that communicates with LoRaWAN communication. It's our hardware, firmware, and software. They are our dashboards, and all the technology it's ours from IT. This is one area that we work for several years, 5 years ago. But we supply electric energy here in Portugal. We started this area of work 8 years ago. We supply natural gas, and we work in energy efficiency from the beginning. Our company has 12 years, and we started working in indoor air quality. It's the beginning. It was the beginning, and we work just in energy efficiency for public buildings for 6 years, just in this area. Then, but it's energy efficiency that it's what defines us. We work in that area, and that's what we like to do. It's area that we're going to continue to expand. This project refers to improvement in terms of energy efficiency. It's from Termas da Fonte Santa. like you can see in the picture in this slide, and we change the boilers to geothermal heat pump. I'm going to present and make a short introduction about geothermal heat pumps. Geothermal heat pumps are able to extract the energy accumulated in the soil, but also in the groundwater, and conduct the respective thermal energy into the building. The water temperature in the subsoil is in the depth is stable, and we can extract all the energy. And the COP, the coefficient of performance, is stable. It's one of the advantages of these products. And we can produce heat and cold. Then I can change. It's impossible to change the slides. I don't know why. Sorry.
It takes a bit of time.
This is the slide from my presentation and the presentation of the company. This is the region that we apply this project. It's in the interior of the country, in Portugal. It's a very cold region. The temperature it's very low in the winter, and it's very high in the summer. I'm trying to change the slide again. It's not changing. Okay, now we have some pictures about the project. This is the boilers that we have, and we have a chiller. Why? Because in this building we do cooling in 1/3 of the building, and we heat the building in the same time. In this moment, what is doing, we have two sources of consumption of energy. It's gas to the boilers and the electric energy to the chiller. What we have done, we changed the technology to a geothermal heat pump, because we have geothermal water in this building. And the cooling of the buildings, it will be for free. Why? Because the chiller, the heat pump, it will be 4 pipes, and the cooling, it will be for free, and we just will spend energy for heating. We can because it's not for heating; it's the total consumption of the geothermal heat pump. It will half of the consumption. Why? Because we will stop the consumption of electricity from the chiller that in this moment is just doing cooling. You can see in this slide, the green graphic, it's the consumption of the chiller. We see that the consumption is stable. It's about stable. It's 30 kilowatts, and this consumption it will be stopped, and we'll just have consumption of the heat pump that we will put in the project. This is the table in blue. It's the cash flow that will be generated by this project. We will invest the properties of the project of the building. We will invest 100,000 euros, and the return, it will be 15%. The return of the investment, it will be about 15% of the investment. The savings, it will be 83%. It's not normal. The investment in energy efficiency in Portugal will have a so big impact. But when we do the energy audition of in the building, we will see that if we take the consumption of the chiller and we change to a heat pump, that coefficient of performance will be stable, about 4. We will have a very high savings for this building. So our expectations are very high for this intervention, and we will see for very close how will be the behavior of this building. This building have another particularity that it just work in the summer, and we will change to a heat pump. We know that the gap between the temperature outside and inside the building it's very important in heat pumps, and this building will produce heat in the summer. That's the game changer for this intervention. Then we will see what will happen in the future, but I think it will be very good. This is the investment that will be done. It's very low compared to the size of the building. It's just a small intervention. Okay, for now, I think the presentation, it will be like this. We will change just the machine in the building that is changed to the boilers to heat pumps. And if you have, who is listening to us or my colleagues who have some question, please, I will be glad to answer. Thank you for listening, and okay, then it's in your hands again.
Thanks so much, Carlos. So that was very interesting. And you can see the significant savings that Carlos was showing, as well as his table of figures, which I found very interesting. And I will take a look again after this meeting. And it was also interesting, the story of Carlos of with wood boilers, and then company is also specialized in lighting. And then they moved to this project with heat pumps, and they saw the major savings that can be attained. So very nice. I'll take a look at the table afterwards, and I encourage the other participants to do so as well. Thank you again, Carlos. Moving to our fourth presentation. Our fourth presentation will be by Gregor. Gotz. He coordinates the geothermal energy research at the Geological Survey of Austria. He recently coordinated the international projects of GeoEra Muse and Geoplasma CE. He has a master's degree in geophysics from the University of Vienna, is the co-founder of the Austrian Geothermal Association, as well as being the vice chair on geothermal energy at the GeoEnergy Expert Group of EuroGeo Surveys, and chairing the Cost Action Geothermal DHC. Gregor, floor is yours. Looking forward.
Thank you very much, Dan, for the introduction. Welcome to my presentation. It's a pleasure to be here and exchange some ideas. So I would pick up now some arguments given by Javier before. We are now more talking about the scientific strategy point of view on the combination of geothermal energy and heat pumps. So I was already introduced, so I skipped this one. So when we talk about ground source heat pumps, well, I would like to start with defining a different technical term which will describe the situation maybe more properly in the future. So already it was discussed, and the idea is also going in my mind that we not say deep shallow geothermal anymore, but call it better ambient geothermal, so ambient temperature level. And then geothermal is one part of the family of aerothermal systems, hydrothermal surface water systems, and the ground source systems. And normally we looked at single family homes, like indicated on the right-hand side of my slide. So we are looking about shallow aquifer systems up to 30, 40 meters maximum, borehole heat exchangers up to 150 meters, or horizontal systems, of course, connected to a heat pump. This is the classical understanding of a ground source heat pump in Europe. And we look at the market, and I took the ECHEC market report on this. So we can say that more than 2 million systems, units installed, producing around 56 terawatt hours. at the average capacity of 12 kilowatts. So this is important to keep this figure in your head, and you see the leading countries he's sorted for the sales, Sweden, Germany, France. And I took the same numbers and I made a little bit of different statistic and want to show you some of them. So here you see a cross plot of the diffusion, that means number of ground source heat pumps per 1,000 households against the growth rate. So the sales 2019 towards the stocks 2018. And here I put just some, it's a semi-logarithmic scale, so it's not linear. And I made a trend. You can see this here just for the orientation. It doesn't, but if you look at this trend and you draw a line, and you can very nicely see there are some parallel countries following parallel lines. And these lines, they indicate the emerging markets. So we already had a presentation from Spain today. So Spain can clearly can be seen as an emerging market at a low diffusion rate. It's less than 0.1 units per 1,000 households, but a 20% growth rate. And it comes to Sweden, which is a very major market with an incredibly high amount of ground source heat pumps by households. So they have 12% of Swedish households use ground source heat pumps. And you see other countries like Austria, where I'm from, Denmark, Netherlands, Poland, they are more or less following the same trend. But if you look at the distribution, you see parallel trends. And I want to highlight this in this sketch here. So if you go to the left of this line or the average, you see those hindering conditions. So you can see a cluster, France, Ireland, Slovenia, for instance. So they had been well developing, but then suddenly the development cooled down. And mostly this is depending on barriers, and these barriers can be highly dynamic. It's not just about incentives or fundings from public sources. It's about energy costs, taxations on energy. It's also about awareness and acceptance. And on the other hand, we have this clearly underdeveloped market where both is low, the diffusion rate and the growth rate. On the other hand, we see Estonia, for instance, which they're overperforming. They have a very good situation, and that's why it's outside of this sketch. So, okay, I see there's some problem with my slide, but doesn't matter. So I was asking myself, so we know that heat pumps, they are developing. We see growth rates more than 10% per year. So this statistic was taken from EHPA. And the question is the same for geothermal. I mean, I just showed you these statistics before. And here you can see the brown bars here, or maybe it appears like black in the bottom line. These are the ground source heat pumps. What you see here is the air-based systems. And it's true, these systems, they are really developed, plus 300% if you compare it to 2006. But what happens to the ground source heat pumps on a European scale? Plus minus zero. And this is something where we need to think about. Why? Because both is I don't want to talk against aerothermal. That's not my point of view. But we have to consider also what happens to the electricity market, and we need to avoid over electrification of the heating market. And you see, it's a recently published paper from September this year from the University of Cologne. It shows that the peak demand, the cooler it gets, here is the ambient temperature. So we are in the -5, -10. This is valid for Northern Europe, not for whole Europe. But the relation between the energy from the electricity grid and the heating demand peak season, it's not linear, it's quadratic. And we have to consider this is not only a few hours per year, but these are really peaks which have to be carried by the grid itself. So it would be important to find a good balance between different sources of heat pumps or heat in general. And if you look at the Austrian market, this is an example where geothermal or ground source heat pumps are still very important. So if you look at the small scale systems, and I mentioned before 12 kilowatt as an average, so you see it's clearly dominating by aerothermal systems, so 80% plus. But if you go to the large one, because there are also the technical limits, for aerothermal. In the moment, we have share of more than 60% by ground source. And this is where we should look in the future, in my opinion. And I would like to highlight some findings from Heathrow Roadmap Europe project. Maybe most of you are well aware of this project, recently finished 2 years ago. So it says that the decarbonization of the heating and cooling sector, this is possible, and it doesn't need to be, new technologies don't need to be invented for this. And also it says that biomass doesn't need to be expanded in a dramatic way. They propose 2 approaches: district heating system in urban areas and heat pumps. They are the 2 main concepts to substitute fossil fuels. And geothermal can play a role in both, and also heat pumps play a role in both. And I would like to highlight this in this sketch. So on the left-hand side, this is you see the generation, the development of different district heating grids. So we're starting at the early stage in the late 19th century with hot steam temperatures above 200 degrees Celsius, going down to the next generation. So actually the 4th generation is already at temperature levels around 50, 60 degrees. They already using heat pumps to modulate the grid, but they are more or less centralized. And in the same manner, geothermal energy can provide to these grids. And we have a huge portfolio of technologies we can use for. We're talking about ambient geothermal at the very low temperature levels. So this is also interesting for low temperature underground thermal energy storage and free cooling. Was mentioned in the first presentation. Heating and cooling. Cooling is the, let's say, the new added value of using geothermal, and can go up to high enthalpy systems, more than 200 degrees Celsius. But what is indicated in this triangle is the lower the temperature gets, the more different technologies you can apply and the more resources are available, because these high enthalpy resources you only find on a very few spots in Europe. And so the idea is that the challenge will be going towards to low temperature heating and cooling grids, and for several reasons. First, we have a brighter portfolio of renewables we can use. The second thing is that it's also important to match the demand with the heating and cooling demand with the available sources. What does it mean? This calls for a kind of exergetic polarization. That it doesn't make much sense to use high enthalpy energy carriers like electricity for a low energy, low enthalpy use like space heating and cooling. This same for green gas. This is they are very important, and they will play important roles if you want to decarbonize our steelworks, for instance. Other manufacturers are using temperatures way above 500 centigrades, but I don't think it's so much needed for the low. So we should aim at having a high share of ambient heat and a low share of electricity in this sector. And the 5th generation low temperature heating and cooling grids, they are one way forward to this. So having decentralized heating pumps, for instance, temperature levels of the network itself below 30 degrees Celsius. This concept, it started quite some while ago. As you see here, a statistic about the 5th generation district heating systems, already dated back to the late 1970s. But just recently, in the last 10 years, it really started to develop across Europe, starting in Switzerland. And we can report at least more than 40 systems now in total in Europe. And if you look at this sketch here on the right-hand side, it shows the different energy or heating or cooling sources. And you can see that it's a big portfolio combining solar thermal, waste heat, aerothermal systems, ground source systems. But ground source geothermal plays a major role. This is the largest share of these systems. So already coming to my conclusion. So how could the new networks topologies look like? So where is the way forward, let's say, to a proposed geothermal decade, like indicated by national organizations of like a European Geothermal Energy Council. Well, there are two important roles, and it's a kind of a shift of paradigm how to use geothermal. It's not just about the base load, because geothermal has a low OPEX, and so that's a very well-established reason to use geothermal. But what comes more and more important is to use geothermal as a storage. As a long-term storage, in the medium-term storage, this gives an added value to such networks, because you can shave the peak. And as far as it's possible with storage, of course, still you might need some high enthalpy energy carriers with a low apex for your peak load, which can be still green gas or can be power to heat. That all these things might work to a certain extent. And these new topologies, of course, they have fluctuating renewable energy sources. Some of them, if you know, demand is here, can be stored in the subsurface, but some of them make a lot of sense to be used in intermediate seasons, like ambient air, aerothermal systems. When it's in spring, autumn time, they have very high efficiencies and they bring an extra benefit to the system. In the center of such grids, and also talking about high temperature grids, heat pumps play a very important role for two reasons. First, they modulate the system, so they can control the different energy loads inside the system, as already mentioned before. And secondly, they can bridge the gap between my heating demand and my energy source available. And this, I guess, will be very important when we look at high temperature heat pumps in the next years, because we have plenty of still fossil supplied heating networks in Europe running at very high temperature levels. And we need to find solutions to decarbonize such systems. And of course, we're not talking about single island networks. We think about topologies which networks get connected to meshes, balancing the energy between such systems, which giving more opportunities to include renewables. So my main conclusions for let's say the next 10 to 20 years from the geothermal point of view are that if you look at this at the market statistics, so the units sales, so at small houses, single family houses, with high efficiency, I think there are not so many arguments speaking for ground source heat pumps, because people look at the first investment. But for renovated building, and I would say the threshold is above 50 kilowatts, I would say there is certainly an option for geothermal or ground source heat pumps. And as I mentioned before, storing waste heat is one of the main opportunities for geothermal energy. They've retrofitted and upgraded fossil-fired heating and cooling networks. Also talking about turning a high-temperature heating network into a heating and cooling network by using absorption heat pumps, for instance. And what I also conclude from my point of view is that we should really focus on the urban areas, especially for geothermal, because then they give a lot of advantages. So if you shift the energy system to the subsurface and use and save surface space for other applications. Well, that's all from my side. I hope I was staying in time, and as mentioned before, I'm the chair of Geothermal DHC. This is a cost action which addresses the inclusion of geothermal energy into heating and cooling networks, and we are an open network. And if you're interested to join us, we are also looking for industrial partners. Please contact me or visit our website. So thanks a lot, Dan, for having me.
Thanks so much, Gregor. So that was very interesting, especially how you did the data visualization, the analysis, and Heat Roadmap Europe is always a very good source of information. And again, encourage everyone to take a small look in that as well. We are running a bit off schedule, nothing to worry about, as let's be honest, we did not foresee it to be actually 10 minutes each presentation. The last speaker, lastly, is James Standley. He is a managing director at Kensa Heat Pumps. Kensa manufactures the UK's widest range of award-winning British-made ground source heat pumps. As managing director, James is responsible for delivering customer and shareholder value through Kensa's manufacturing, field delivery, technical support, and NPD activities. James, the virtual floor and microphone is yours.
Thank you very much, Dan, and thank you for having me, and thank you to all the other speakers, and some really interesting stuff there. Today, I'd like to talk to you about our vision for the decarbonisation of heating and cooling, and I think we'll find it's very similar to the one that we've just heard from Gregor. Decarbonising heat is hard. There are no silver bullets. If there was a solution that ticked all the boxes all the time, I think we would have probably done it already. That said, the system that I'd like to present to you today is what we believe is the very best system for homeowners, for governments, for the electricity grid, and for our environment. The foundation for this vision, as we've heard, is an ambient temperature district heating and cooling network, which consists of a series of pipes in the ground connecting every property together, and fluid running typically between 0 and 20 Celsius, running through those pipes, which has been described both by Javier and Gregor as a 5th generation heating and cooling network. Connected to this heat pump, or connected to this grid, are individual heat pumps that upgrade the temperature you need for heating purposes and for hot water, and downgrade it, chill it for air conditioning and cooling purposes. So every home has its own heating appliance, and in that way it mimics what a lot of us are familiar with in the gas grid. In addition, we also have the opportunity with the lower temperature heating network to provide passive cooling or free cooling, which can help overcome the overheating problem we often have in many new built houses today. To balance the effects of the heating and cooling and to spread out any seasonality, we can have a number of different heat sources to bring the loop back to ambient, from boreholes to aquifers, mine workings, or the rivers, lakes, or even the sea. All of the waste heat that's produced by the cooling goes into the ambient temperature loop, and all of the cold that's produced as a byproduct of the heating goes back into the loop. So we're not wasting all that energy out to atmosphere. And one of the benefits is that the efficiencies of both systems, both the heating and the cooling, are improved, and you can also store that energy in the loop between the heating and the cooling applications. So none of that's necessarily hugely novel or different. It's a fairly simple system. We've heard other speakers say about the same thing. So what's so good about it? One of the big benefits is that this is not just a low carbon heating system, it's the lowest carbon heating system. Presented here some figures on the various carbon efficiency or carbon factors for a number of different heating types, and ground source heat pumps you'll see there at the bottom of the list. If we're serious about net zero, then this should be the default choice. The other benefit is that the introduction of more renewables to the electricity grid is going to make these numbers even better. And these numbers for electricity, air source and ground source are going to get even lower as we add more renewables to the electricity grid. The electrification of heat is going to require a little bit more electricity generation. And this system, the one I've just described, has the lowest impact on the electrical grid, making the changes we need to make as cheap as possible. As Gregor said earlier, the way we decarbonize heat and the way we electrify heat is going to affect how many power stations we need. As water source and ground source heat pumps are the most efficient available, that becomes really important when we deploy this technology at scale. I'm going to show a slightly different way of the same thing that Gregor showed us earlier, by illustrating the effect of decarbonising all of the homes in the UK with either air source heat pumps or ground source heat pumps. And on the coldest day, when we have the peak demand, we need some additional electricity capacity, which could be 2,400 additional 10 megawatt wind turbines, or 8 3 gigawatt nuclear power stations like the ones that are being built at Hinkley and Flamanville. So those are unnecessary additional electrical demands on the grid that won't necessarily come cheap. Some people are suggesting that hydrogen, and particularly green hydrogen, is the right answer for our home heating needs. We agree that that's not necessarily the right way for that particular technology, because in the same scenario, you need an extra 26,000 wind turbines. Another benefit of individual heat pumps connected to an ambient temperature loop is the flexibility you get for the electricity grid. Our future electricity networks with more renewables will value their electricity higher, will value electricity very highly. And heat pumps connected to an ambient temperature loop can run at any time of the day or night without any loss of efficiency. When you combine that with some smart controls, this will mean that homeowners can continue to be warm while only using electricity when the grid can support it, which we think is probably either during the night or when the wind is blowing. When you factor in all of the benefits that I've just mentioned, you get not only the lowest carbon and the lowest grid impact system, but also the one that's the lowest running cost. Give you a quick example of that. At my house for the last year, I've had a Kensa Evo heat pump. I'm getting electricity from Octopus Energy on their Agile tariff, which is a half-hour time of use tariff. And I've got smart controls from Homely Energy that join all that together to make me warm when I want to while using the cheapest electricity. Over the past year, as a result of some analysis I've done, I've got heat at 2 pence a kilowatt hour, which is cheaper than even the disastrously cheap gas that Javier mentioned earlier. Now, clearly, there is an opportunity with running costs that low to have provided the infrastructure in advance and have charged a service fee, much as is done elsewhere, while keeping the benefits for the homeowner and the outcomes for them good. So everything I've just mentioned, you can get from an individual standalone ground source heat pump. So what are the benefits of the ambient loop infrastructure and adding that in? One of the big benefits is you get a lower installation cost. With your economy of scale, you are able to reduce the cost per kilowatt as it's installed, which is a key benefit and a key barrier to the installation of geothermal and ground source systems. You get a small skills gap for the installers. So an installer who's used to fitting a gas boiler or an oil boiler, now he's got 2 water pipes coming into the property rather than a gas pipe coming into the property, and that's not too much of a shift for them to move from one technology to another. We don't ask the people that fit gas boilers to design the gas main that goes up to the house, so why would we do the same thing for a ground source or a geothermal system? So by separating out the ambient loop infrastructure from the houses, that provides an opportunity to keep that skills gap smaller and enable a faster move to the decarbonisation. If you have individual heat pumps in each property, that means that the homeowners retain control of their costs, control of their energy provider, and you don't necessarily get locked into the 20 or 40 year cost of heat things that you might end up with a previous generation district heating system. As I said before, you get the opportunity to add cooling loads to the loop, and with a bigger load, you're more likely to come across a supermarket or a data center or something else that has a cooling load that will allow the efficiency of the whole system to be improved. And finally, as we move to more rapid decarbonisation, you get the opportunity to do it on a street-by-street basis, which will be a huge benefit for the planned implementation of the decarbonisation of heat. An example of how we're putting this system into place is these tower blocks, which sister company Kensa Contracting has finished installing 183 heat pumps over 3 tower blocks using ambient temperature loops connected to a borehole ground array, and down 300 or 400 meters, which looks like it could be an exciting cost-saving opportunity moving forwards. This project was also, I'm pleased to say, one of the part of the winning heat pump City of the Year award that was announced this morning. So, in summary, it is possible to combine the best features of district heating, heat pumps and smart controls into a 21st century energy system that provides a combination of the lowest carbon, the lowest running cost and the lowest grid impact possible. We're delivering this solution right now into social housing retrofit and in new build. And if we were to decarbonize on a street-by-street basis, in a coordinated, planned approach, this could be the default heating system architecture in 10 years' time. Thank you very much.
Thank you so much, James. And if you would click one more time to go to the last slide. Thank you so much. So we are a bit behind schedule, which is fine. Again, you can send your questions afterwards as well, and we will make sure they will reach the particular speaker that you have addressed them to. There were very nice presentations, and of course, to be honest, I have a lot of questions myself, and one of them would be for James and Gregor, and this would be, so what are the biggest obstacles in shifting district heating networks towards renewables and implementing 5th generation low temperature heating and cooling grids? What are the obstacles then?
Want to speak first? Okay, I would start from my point of view. For the low temperature heating and cooling grids, the problem is to have to bridge the gap between investor expectations of real estates and those people who live in the apartments. So the one want to have low investment costs, the other one want low operation costs. And I can tell this for the Austrian market in my experiences. What is missing is a business model to bridge this gap. Somebody who does the investment into the system, operates it, and provides the energy, and independently from the constructing companies or the investors, real estate investors, and then independently from the clients.
Thank you, Gregor. James, the
Yes.
same questions. Sorry.
I would agree that certainly the cost of the infrastructure is the challenge, and providing the right business model that enables the benefit of the ground array, the 150-year infrastructure that you've put in place, to be spread out over many years rather than paying for it all up front. That's probably the biggest barrier, and coming up with the methods for doing that and persuading those people who want to invest in something that it is really boring.
So we talked about investment, the price, the upfront price. We touched upon a little bit about installer skills, the professionals that you're actually talking to of installing new heat pumps, for example. We talked a little bit about user knowledge and their perceptions, as well as the price of gas. We haven't talked a little bit, well, Javier talked a bit about policy and policymakers. So how would you rate the obstacles from upfront price investment, let's say, the user perception, policymakers, and the funding that they give to projects such as yours, and then all the way to skills? Which would be the most important, and which can be tackled in the next 10 years, or at least touched upon, and which is something that you would say, oh, this will take 20 years to do? Let's start with Gregor. So you said investment.
Yeah. I would like to give an example for Austria as well. This is something very easy to change. So subsidies, they come from regional governments in Austria for heat pumps, for instance, or for renewable energy sources. And we observed that in Austria, I think 2/3 of all heat pumps sold, they don't receive any subsidies because the government has high expectations on the COP. And at least in the past years, maybe some of these, they didn't fund aerothermal systems. But the problem is that the funding you receive, they just balance the extra costs you would have to install a ground source heat pump. And it's more a psychological problem because still you, as a house owner, you need to contract at least 2 companies, a driller, a planner, and the third is the installer, of course. And even if it doesn't cost you more in the first in the upfront investment, you have much more work to do. So what happens? People said, no, I don't want to have the subsidy. I don't want to have these incentives. I buy the system, which in the end brings the same price. So how to address this problem? First, it would be nice to have all-in-all solutions. So somebody who does the service for you and all kind of services from drilling to planning. This mostly you need somebody who has the capital to do so, that their energy suppliers should do this job, but it's not done in Austria. The second is you would raise a little bit more the subsidies for ground source heat pumps, so give a small financial benefit, and then this psychological problem can be addressed. It's more a psychological problem, in my opinion.
Very interesting. And I'll be honest, we are working on a project in Ireland with one-stop shops where we're trying to tackle exactly what you said, of having everything in one easy to approach and get the information from, well, point for the client, right? What do you think, Carlos? So would you think let's say psychology of clients or the upfront investment or policy, this can change in the next 10 years? Or is it, oh, you faced a lot of problems in Portugal that you think will take a long time to solve?
To be honest, the first retrofitting that I have done with a heat pump, it was this one. And I have done, I think, I don't have for sure, but 100 to 150 retrofittings in buildings here in Portugal. Normally I change to boilers that work with wood, with pellets, not with heat pumps, because we have several technical issues about the changing a boiler to a chiller, to a heat pump. The temperatures are different. When we see a boiler, we see that they work at 80 degrees, and the return of the water is about 65, 70 degrees. We know that a chiller, to get a good efficiency, it works here 45, the heating of the water, and the return it will be 40, 42. The gap between the two temperatures are just 5 degrees and not 15, 20 degrees. So all the equipments that are inside the building, fans and air units, everything that are inside the building, we have to change it. And the caudal of the water, the bumps that pumping in closed circuit, the water, we have to change the piping, everything. It's not an obligation, but it's an issue that you have to see very well. So when we change for a swimming pool, the equipments, or a big building, shopping mall, and that kind of buildings, we have several problems that we have to resolve. And it's not easy. It's not consensual, the changing. The cost of the energy is the same here in Portugal, from pellets or the heat pump. The investment is different, but it's not so different. The problem is not the initial investment. We can invest in a heat pump or with a boiler, but we have to change many things. So it's not easy to do it. Sometimes I speak here in Portugal and I say to the brands that sell heat pumps here in Portugal, and I say, if you prove me, give me a proof that it's a good change in buildings, I will do it. So give me the numbers, give me everything, and I will put heat pumps in buildings. And until this moment, I don't have any document, with an Excel, with several algorithms that say that it's possible to do it. It's not easy to do it. To do retrofittings, not new buildings. New buildings, it's another thing. It's a project from the beginning. To change, I think we have problems here in Portugal. But if we see the numbers, they are good numbers. The investments are good. So investment is not a problem. We have technical problems, not financial problems. Here we have structural funds. We have the 2020 here in Portugal, which we do much investment in the universities. I make my biggest project. It is in this moment running. It's more than 5 million euros in the investment in the university, and I have done several projects. So that's no problem. We can change a lot of things in buildings. We can improve much the energy efficiency of buildings. But heat pumps, I have done much projects, new projects. I have done about 600 projects for changing. But to heat pumps, it's not easy to do. So we have to work, in my opinion, in engineering. First, we have to work in engineering to see how it's possible to do it. Then see it in the financial way. If we work in that two areas, it will be a success. Change the equipment.
Thank you, Carlos. So on Carlos's opinion, because he works on this in Portugal, and this is the first time he installed this example with the heat pump, is actually part of the project that we're in as well, the project of GeoAtlantic that we discussed before. So Adrian, coming from Ecoforest, how would you respond to Carlos? He said he has no numbers. There are some problems in the retrofit. What would you say to that?
I think that, okay, I can understand the point of Carlos, but from our point of view, from the manufacturer's one, in fact, we have a lot of retrofit installations done with ground source heat pump nowadays. I think that is just not question of numbers. It's question to have a future vision of the house, of the value of the house. Finally, installing a ground source heat pump is an added value for the house. It's also there is also a lot of savings during the year in question, thanks to the efficiency of a heat pump. He said that they are using sometimes pellets boilers. We are also manufacturing pellets boilers. And finally, another advantage of these technologies is the maintenance. It's very low maintenance if we compare with other technologies. I think that heat pumps are an option, as I told him during my presentation, for all type of projects, for new and for retrofits. Of course, we need to study of each of the cases and bring the exact solution for each one. The best one solution is, but I think that there is always a possibility to include a ground source heat pump in a project, on any type of typology of project. And I will be glad to share with Carlos data and crossing numbers and about his projects and check about possibilities, of course.
That is great. And then, because we're running out of time, just to move to Javier, because you said exactly what Javier was saying about having the vision, utilizing the technology that we have, because it's already here. So what would be, for you, Javier, what would be the obstacles? Would it be policy, investment, user knowledge, price of gas, for example? How would you stack these?
Okay, that's a little bit a mixture of all of them. Let's say, depending on the market and on the conditions, there are some of these obstacles are more or less important. So we have to, let's say, prioritize one or the other. Going to the question raised by Carlos and Adrian about the retrofitting market, it is very important that we also have a clear picture on, let's say, where it is more feasible or not to install ground source heat pump in a city. There was the results from a project which ended 2015, which was called Geothermal, where I had the pleasure to participate, in which we established different, let's say, areas or typologies of areas in cities in which it is more or less likely that geothermal heat pumps can be, let's say, have successfully, or buildings can be successfully retrofitted with geothermal heat pumps. There was a question of administrative permits, of what is the, let's say, the density of the urban setting, and what are the possibilities of working underground, etc., etc. All this was analyzed in this context, in this geothermal, and if you have time to look at these, let's say, conclusions, I think it would be interesting. Also, the question of the mapping of resources, the knowledge about the soil conditions, and so on, it's also could be an important barrier for many times it is let's say, difficult to establish, let's say, the boundaries of a system, the possibilities of a system. So I think these are all important points. I think a very important barrier in many markets, especially emerging markets like Spain, is the lack of knowledge or lack of integration between the architectural world and the let's say the systems or the manufacturers of energy systems. And I think this is something teaching and let's say awareness raising is also a very, very important question. So I think it's all together, and depending on the market, it may be different flavors of barriers, I would say.
Thank you, Javier. And last question from for James would be, so what would you need in the next 10 years, let's say? What would be the top priority if you were to wish for something from the government, from private investors? What would the two things would be that you would wish for, to put your vision and the presentation that you shown us, to make it, let's say, ready for mass deployment and mass deployed?
Okay, two things. I would hope to get across the benefits of the flexibility of the ground source heat pumps, and particularly the benefit on the electrical grid. So the flexibility and the reduced peak demand that we're going to need if we electrify using ground source heat pumps as opposed to other variants. I'm trying to get a system-wide understanding that that's a real thing, and that's going to cost some money depending on how we do that. Monetizing that flexibility would be one ask, and the other would be realizing the cost of the fossil fuels. So getting that difference between electricity price and the burning of the fossil fuel, and what that difference is, so that it doesn't pay to pollute, which is pretty much what we've got at the moment, particularly in the UK, where we have electricity at one price and gas at another. And obviously, as Javier just said, that's different in different markets. But an understanding that how government choose to levy taxes on one fuel or another will drive the decarbonisation of heat or not would be a big ask as well.
Exactly. I mean, someone always has to pay in the end. It's not direct. It may be a forest fire on the other side of the planet, but there are some benefits that are a bit intangible, especially for the user. Energy security, right? Having
Indeed,
energy
yeah.
locally rather than having it shipped, and all sorts of the pollution involved in that, and disruptions due to, well, pandemic being one of them. Mm-hmm. Then yes, of course, the other being that, yeah, we also have to change the psychology of the user and make them see this vision, and that everything has a cost, right? So gas may be cheap, but it's transported from somewhere. It has some strings attached maybe to it. So a lot of intangibles that go into that. With that being said, we are a little bit over schedule, so I would like to thank all of our speakers. All the recording as well as the presentations will be available to you in a follow-up package. And then I would like to thank my team as well for organizing this. And I would like to see you, the attendees, at the rest of the events that we have, to also take advantage of the possibilities of the online platforms that we use. Now that we've gone fully online with our events, and we have a lot of them here at the HPA, participating in them has never been easier, right? And it's for free as always, interesting presentations, interesting discussions. And I wish you a very pleasant afternoon. And again, thank you for the speakers and the attendees. And have a great afternoon. Bye-bye.
Thank you.
Bye.
Thank you. Bye-bye. Thank you.